Welcome back to Mr. Vaughn's classroom, where math is made easy. Before we get started on this video, I'd like to ask you to please hit the subscribe button, give this video a thumbs up, and engage with a comment below. In this video, we're going to be looking at Unit 7 on quadratic equations, Lesson 24, using quadratic equations to model situations and solve problems. This lesson is the last one in the Illustrative Math Algebra 1 curriculum. The learning goal in Lesson 24 is to analyze a situation modeled by a quadratic equation. We have 3 learning targets in this lesson. When we get done with the practice problems, we'll come back, review these learning targets, and ensure you've learned everything you need to as we wrap up this Algebra 1 curriculum. Learning target number 1 says that you can interpret information about a quadratic function given its equation or a graph. Learning target number 2 says you can rewrite quadratic functions in different but equivalent forms of your choosing and use that form to solve problems. In situations modeled by quadratic functions, you can decide which form to use depending on the questions being asked. Now we can begin the practice problems for Lesson 24. Practice problem number 1. The function h represents the height of an object t seconds after it is launched into the air. The function is defined by h of t equals negative 5t squared plus 20t plus 18, and the height is measured in meters. Answer each question without graphing. Explain or show your reasoning. Question number 1. After how many seconds does the object reach a height of 33 meters? So, we have the freedom to solve this any way we want according to this practice problem. What we can do is we can simply take the function that they gave us, so negative 5t squared plus 20t plus 18, and since it represents the height and they want the time when the height is 33 meters, we simply set the equation equal to 33. Now, the first step is to set it equal to 0. So we're going to subtract 33 from both sides. This will give us negative 5t squared plus 20t, and then 18 minus 33 is going to be negative 15. Now that it's set equal to 0, we can identify a, b, and c. A is going to equal negative 5. B is going to equal 20, and C is going to equal negative 15. I'm going to put these into the quadratic formula. We have negative B, which is 20, plus or minus the square root of B, which is 20, squared, minus 4 times a, which is negative 5, times c, which is negative 15. And all of this is divided by 2 times a, which is negative 5. This gives us negative 20 plus or minus the square root. 20 squared is 400. Then negative 4 times negative 5 is positive 20. And positive 20 times negative 15 is going to be 300. Negative 300. Then 2 times negative 5 is negative 10. $400 minus 300 is 100. And the square root of 100 is plus or minus 10. Negative 20 divided by negative 10 is going to be 2. And plus or minus 10 divided by negative 10 is going to be plus or minus 1. So the two possible answers are that the height is 33 meters when the time is 3 seconds, and when the time is 1 second. Number 2, when does the object reach the maximum height? To solve this one, we're going to use the knowledge that a parabola is symmetric. So if we know that the object reached a height of 33 meters at both 1 second and 3 seconds, then the x-coordinate for the vertex is going to be halfway between them. So we're going to add 3 plus 1 and divide by 2. This is going to give us 4 divided by 2, which is 2 seconds. That is when it's going to reach its maximum height. And finally, number 3, what is the maximum height the object reaches? Well, if we know that the time is 2 seconds, we can simply substitute 2 in for t. So we have negative 5 times 2 squared plus 20 times 2 plus 18. 2 squared is 4, so we have negative 5 times 4. 20 times 2 is 40. Now we have negative 5 times 4, which is negative 20. And we have 40 plus 18, which is 58. And negative 20 plus 58 is 38. And since we're measuring the height in meters, that is 38 meters. So this is an example of how we could use quadratic functions to model projectile motion objects and make predictions about the times and the heights of these projectile objects. If you have any questions about any part of this first practice problem, please leave a comment below and I'll get back to you with any clarification that I can offer. Practice problem number 2. The graphs that represent a linear function and a quadratic function are shown here. The quadratic function is defined by 2x squared minus 5x. Find the coordinates of r without using graphing technology and show your reasoning. So they've given us the function for the quadratic, but not for the linear. So that's the first thing we need to do. We need to model this linear function. I know that I have 2 points here. I see that I have the y-intercept. So what I can do is I can find the slope-intercept form. So what I'm going to need is the slope. Well, the slope is the second y, which is 0, minus the first y, which is 5, divided by the second x, which is 2.5, minus the first x, which is 0. This is going to give us negative 5 divided by 2.5, which is negative 2. Now that I know what the slope is, and I know what the y-intercept is, I can do the slope-intercept form. And the slope-intercept form is y equals mx plus b. So the slope, negative 2x, plus the y-intercept, which is 5. So now I have the expression that represents the quadratic and the expression that represents the linear. Now R is at a point of intersection. So at points of intersection, these two expressions are going to equal each other. So we are going to set the quadratic, which was 2x squared minus 5x, and we're going to set that equal to the linear, negative 2x plus 5. Now what's going to happen is that we're going to find 2 answers for x. One of those answers is going to be 2.5, where they intersected over on this right side. The other answer is going to be where they intersect at r. Once we find that x value, we can substitute that x value into either of the expressions and solve for y. So the first thing I would do is add 2x to both sides. This will result in 2x squared minus 3x equals 5. My next step would be to subtract 5 from both sides. That is going to result in 2x squared minus 3x minus 5 equals 0. Now I can identify A as 2, B as -3, and C as -5. I can substitute these into the quadratic formula, and I have negative b, which is -3, plus or minus the square root of b, which is -3, squared, minus 4 times a, which is 2, times c, which is -5. All of this divided by 2 times a, which is 2. -3 becomes +3, plus or minus the square root. -3 squared is 9. -4 times 2 is -8, and -8 times -5 is +40. And then on the bottom, 2 times 2 is 4. Under the square root symbol, 9 plus 40 is 49. The square root of 49 is plus or minus 7. So we've got two answers here. The first one is when we add 7. 3 plus 7 divided by 4 equals 10 divided by 4, which equals 2.5. And that is the intersection we already had. So now we need to solve x for the other option, which is 3 minus 7 divided by 4. 3 minus 7 is -4, and -4 divided by +4 is -1. Now we're going to take this -1 and we're going to substitute it into either of the functions. So the easier one would be substituting it into this linear function that we found. Y equals -2 times -1 plus 5. -2 times -1 is +2. And 2 plus 5 is 7. This gives us the answer that r equals the point -1, +7. If you have any questions about any part of this practice problem, please leave a comment below and I'll get back to you with any clarification that I can offer. Practice problem number 3 is the final practice problem not only for this lesson, but for this Algebra 1 curriculum. Diego finds his neighbor's baseball in his yard about 10 feet away from a 5-foot fence. He wants to return the ball to his neighbors, so he tosses the baseball in the direction of the fence. Function h, defined by this function, gives the height of the ball as a function of the horizontal distance away from Diego. Does the ball clear the fence? So what we need to do is simply substitute 10 in for x, because x is measuring the horizontal distance of the fence away from Diego. So we're going to say h of 10 equals negative 0.078 times 10 squared plus 0.7 times 10 plus 5.5. 10 squared equals 100. So we have negative 0.078 times 100. 0.7 times 10 equals 7. Now, negative 0.078 times 100 is negative 7.8. Then we have 7 plus 5.5. That's 12.5. And then we have negative 7.8 plus 12.5, and that equals 4.7. So what this means is that 10 feet from Diego, the ball will be 4.7 feet above the ground. But the fence is 5 feet tall. This means the ball will hit the fence not go over it. So this is another example of how we can model these projectile motion situations and understand or make predictions about what will happen. We know how far away the fence is from Diego, so if we put that distance in for x and we solve the quadratic equation using that input, the output will tell us how high the baseball is above the ground. And then if we know how tall the fence is, we know if the ball makes it over or not. If the height had been more than 5 feet, then it would have gone over the fence. But since the ball was lower than 5 feet, it's actually going to hit near the top of the fence and fall right back down into Diego's yard. If you have any questions about this practice problem or any of the practice problems we did in this lesson, please feel free to leave a comment below and I'll get back to you with any clarification that I can offer. Now, before we end this lesson and before we wrap up the Algebra 1 curriculum, let's go back and review the learning targets and make sure you learned everything you needed to from this lesson so that we can get a good final finish to the curriculum and you'll be prepared moving forward into future math classes. Let's review the learning targets for lesson 24. Learning target number 1 says that you can interpret information about a quadratic function given its equation or a graph. I'm hoping by now you understand how to use the equations or the graphs to find important features like the vertex, the x-intercepts, and the y-intercept. Learning target number 2 says that you can rewrite quadratic functions in different but equivalent forms of your choosing and use that form to solve problems. This means that by now, the hope is that you understand how to switch between standard form and factored form and vertex form in order to find those different features depending on what you're needing, such as the standard form to find the y-intercept, the factored form to find the x-intercepts, or the vertex form to find the vertex. And finally, learning target number 3, in situations modeled by quadratic functions, you can decide which form to use depending on the questions that are being asked. So again, this hopes that you understand what each form is good for doing, what information is easiest to get from it. So again, if you're wanting the y-intercept, then the standard form is going to be the easiest form for you to use. If you have a question about the x-intercepts, then your factored form is going to be the easiest form for you to use. And if you need to answer a question about the vertex, then the vertex form is the easiest for you to use. I hope that everything we've covered in Lesson 24, as well as all of the videos on Unit 7 and all of the videos throughout this curriculum have made sense to you. If you still have questions, please feel free, reach out with a comment below. I'll get back to you with any clarification that I can offer. I hope that you feel prepared as you move forward into future classes such as geometry or Algebra 2. The next topic that I will be covering on this channel will be geometry. I will begin filming those videos throughout the summer in hopes of having them ready for students as they continue on into geometry, generally in the 10th grade. So hopefully you'll follow along. You'll find more helpful information. If you do find this helpful, then in the bottom left of the screen, you should see a video that YouTube believes might help you. In the bottom right corner of the screen, you should see a subscription button for the channel. Please do me a favor and hit that subscribe button. Give the video a thumbs up, engage with a comment, and as always, I look forward to seeing you in the next subject, geometry.